Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 5th, 2025, so just yesterday. This paper introduces a surprisingly compact model that can generate high-resolution images, understand them, and even edit them, all on a single consumer graphics card. The paper is titled Skywork UniPic, Unified Autoregressive Modeling for Visual Understanding and Generation, and it really challenges the idea that bigger is always better. The authors achieve this using an autoregressive model, which is a type of AI that builds its outputs step by step, combined with a clever training strategy to make one unified system. Also, the authors shared their implementation on GitHub. You'll find the model checkpoints in code there, including scripts for text-to-image generation, image editing, and image-to-text. It's all set up for you to try the unified model out yourself. And on Hugging Face, you can find the 1.5 billion parameter model ready to download, along with code examples for text-to-image generation and image editing. Alright, so here we get a nice visual showcase of what this unified model can do. The top section demonstrates its image generation capabilities, showing everything from portraits in different art styles to animals in various settings, and even some pretty creative, unrealistic scenes. Building on that, the bottom section highlights its image editing skills. You can see it changing the entire style of an image, like making it pixel art, and also performing very specific edits, like adding a necklace or removing earrings from a portrait. Okay, so how does it actually pull all of this off? This diagram lays out the core architecture, and the key is a kind of split brain approach. For image generation, on the left it uses a masked autoregressive encoder. This process is great for filling in missing parts of an image, essentially building a picture piece by piece. Then, for understanding an image, on the right, it uses a different tool called a SIG-LIP2 encoder, which excels at capturing the rich meaning of the visual data. Both of these specialized pathways then feed into one shared language model at the center, which unifies the whole process. This table then breaks down the clever four-stage training process. They start with pre-training, then alignment, joint optimization, and finally, supervised fine-tuning. What's really interesting is how they progressively increase the image resolution for generation, starting smaller and scaling up to the full 1024 by 1024. You can see in the loss weights that the model first focuses only on generation, before adding understanding and editing objectives in the later stages. This staged approach seems key to balancing performance and stability. Moving to the results, this chart really drives home the main point. Across these different benchmarks for generation and editing, Skywork UniPic holds its own, and in some cases, it's the top performer. On the DPG bench for text-to-image tasks, for example, it scores the highest. It also puts up strong numbers on the Gedit bench, EN, and IMGedit bench. The most impressive part is that this model achieves these results with only 1.5 billion parameters, while many competing models are over 10 times larger. Okay, so this table gives us a closer look at that DPG bench performance, which tests how well models follow long, complex text prompts. You can see Skywork UniPic here at the bottom, achieving an overall score of 85.5. What's remarkable is that this score is the highest among the other unified models listed, and it's even competitive with much larger, specialized diffusion and autoregressive models. It shows particularly strong results in understanding relationships between objects and the overall global coherence of the scene. Alright, and this figure gives us a great qualitative look at that text-to-image generation. The columns compare Skywork UniPic, which is labeled ours, against other models like Bagel and even GPT-4o. For a really complex prompt, like the one for a giant pixel corgi sleeping on skyscrapers, you can see the model does a fantastic job capturing the specific art style and the scene details. Across the board, its generations are highly competitive in both visual quality and how well they follow the prompt. So, to wrap up, Skywork UniPic really challenges the idea that bigger is always better. It shows that with a clever architecture and training strategy, a compact model can deliver top-tier performance across